This example is a relatively straightforward polar coordinate example. We're asked to find the velocity and acceleration at a time of 1 second, and we're given both the angle and the radius as functions of time. So we'll just need to take some straightforward derivatives with respect to time. So the solution will be velocity, if you remember, in polar coordinates, is r dot. The velocity in the r direction is how fast the radius is changing, plus r theta dot in the theta direction. And so remember, the radius times the angular velocity equals the linear velocity. Okay, so all we have to do is put in the functions of time. So the first derivative of r is 200t. And r is 100t squared. And the first derivative of theta with respect to time is 3t squared. Okay, so that equals to 200t in the r direction and 300t to the fourth in the theta direction. We need to evaluate this at t equals 1 second, which is convenient. So that's just going to be 200 in the radial direction and 300 in the transverse direction. It would be good to know which way u theta and u r are pointing. So we need to know theta at 1 second is 1 cubed, because theta is t cubed, so 1 radian. Okay, so to get the acceleration, you might be tempted to do this. A is dv dt, because you're thinking, oh, I could just take the derivative of this. But you would be wrong. And the reason is ur and u theta, they're changing too, so you need to be able to get the derivatives of the unit vectors. But we've already done that, and that's why we now have dv dt, we know, is in the radial direction r double dot minus r theta dot squared, which is the centripetal acceleration. So r double dot is going out, and r theta dot is going in towards the center. And we have r theta double dots. Remember, the radius times the angular acceleration is the linear acceleration. And this weird, remember the Coriolis thing, we talked about the r dot and the theta dot combining to make an acceleration. And these are in the u theta direction. So we need to put in all the derivatives. So 2 derivatives of r is just 200 minus r 100t squared times theta dot squared. And so theta dot is 3t squared, so that squared is 9t to the fourth. Okay, I'm going to run out of room, so I'm going to continue on the next line. R is 100t squared. 2 derivatives of theta is 3t squared, 6t. Plus 2, the first derivative of r is 200t. And the first derivative of theta is 3t squared. Okay, so simplifying this a bit, it's 200 minus 900t to the sixth. So I'm really glad we're going to do this at t equals 1 second, plus 600t cubed plus 2, 4, 1200t cubed as well. Okay, so the acceleration at 1 second is 200 minus 900 plus 600 plus 1200 in the theta direction, which gives us minus 700 in the radial direction, so pointing in, plus 1800 in the theta direction, and this will be millimeters per second squared. So there you go.